Before we move on to the last set of problems, I want to remind us of some of our exponent rules that we did like back in junior high and in Algebra 1. So if you are multiplying x to the fourth times x cubed, you add those exponents. Okay, it's x to the seventh because x to the fourth means x times x times x times x, and x to the third means x times x times x, and you can clearly see there's 7 of those. All right, now if you're doing something like w to the fifth squared, that's when you multiply the exponents. So this is going to be w to the 10th, because what this really means is you're doing w to the fifth times w to the fifth, and there's 5 w's here and 5 w's here, which is going to be w to the 10th. So when each of the exponents have their own base, that's when you add. If they're sharing a base, that's when you multiply. Now, if you're dividing these, m to the 10th over m to the 7th, we subtract the exponents. So this is m to the third, which we know this because there's 10 m's on top. I'm not going to write them all. And then there's 7 on the bottom, and we can cancel out 7 of them, so on and so forth, which leaves us with 3 on top. I know I didn't write them all out because that's too many. And then the last thing is negative exponents. To get rid of negative exponents, we move them down underneath. If the negative exponent was already on the bottom, so if it was 1 over z to the negative 5, then we would move it up to the top. Okay, so to get rid of negative exponents, you just switch it across that fraction bar. So we're going to use all of that to simplify all of these expressions. Well, not all of them. We're going to do the odds. Okay, so we have s to the 3/4 times s to the 13/4. Since they each have their own base, we are adding 3/4 plus 13/4. So this is s to the 16/4. And of course, 16 divided by 4 is just 4. So this simplifies to s to the 4th. All right, y to the negative 1/2. To get rid of a negative exponent, we're going to drop it down to the denominator. So we get 1 over y to the 1/2. I'm going to write that a little bit differently so you can see it better. Now, this is a totally fine answer. It didn't tell you if they wanted it as a rational exponent or a radical. But if you wanted to rewrite it as a radical, it's the square root of y to the first. So those are the same thing. All right, number 23. We're dividing these, which means we're going to subtract the exponents. So 3/5 minus 2/5 is q to the 1/5. And that is fine. You can leave that answer as it is, or you could rewrite it as the 5th root of q to the 1st. And then number 25, let's come back to that one. That one's a little more complicated. Not quite ready for that yet. Okay, 27. We cannot multiply these because this is a square root, and that's a 5th root. So what I'm going to do is rewrite these with rational exponents. This is 12 to the 1/2 times 12 to the 3/5. All right, so now I can add those exponents. So I'm going to do 1/2 plus 3/5. And I'm going to need common denominators to be able to do this. So I'm going to have to multiply by 2 and multiply by 5. So this is the same thing as 5/10 plus 6/10. So this is going to be 12 to the 11/10. And that's fine. We can leave our answer that way. We could rewrite it as a radical, but I like that answer. All right, let's check out 29. And there's a reason I skipped over to that one. This is not rationalized, okay? We'll talk about this more this chapter, but we don't like to have radicals in the denominator. So the way we get rid of them is we multiply top and bottom by the radical. So that's going to make the numerator a root 3b. And then the square root of 3b times the square root of 3b is just 3b. Okay, and that's how we're going to leave our answer. All right, number 25. I need more space than what's on here, so I'm going to rewrite this problem over here so I get more space. Hang on. Okay. So the problem is 2z to the 1/2 over z to the 1/2 minus 1. So let's see. I'm going to rewrite that as square roots. Okay. So this is 2 square root of z over the square root of z minus 1. And again, we don't like to have the radicals in the denominator. So the way we get rid of that is we multiply by the conjugate. And you did this in Algebra 1. We will practice more with it a little later on in the chapter. But we're going to multiply it by the square root of z plus 1, top and bottom. Okay. So when we do that, we're going to distribute here. That's going to give us 2. The square root of z times the square root of z is just z plus 2 square root of z. Then we're going to FOIL here. So root z times root z is z. And then we have plus square root of z minus square root of z minus 1. And you'll notice those cancel out. So our final answer is going to be 2z plus 2 root z over z minus 1. Okay. So now, if you don't remember that one and 29 very well, that's okay. We'll get to that rationalizing stuff. But hopefully those other ones seem kind of familiar, just applying your rules of exponents in a little different way.